What's up, guys? I am here to explain Leetcode question number 2467, most profitable path in a tree. So in this question we are given an undirected tree with n nodes which are labeled from 0 to n minus 1, which means that we are given a tree and we have been given edges. Now in at every node there is a gate which and every node has some amount as a reward. Okay, also we have two people. One is Alice is standing at node 0 and the other is Bob is standing at some other random node. Okay, now what Bob does is Bob and Alice move at the same time, but Bob moves towards 0 and Alice moves towards any leaf. That's the case, but there is a catch. If both of them meet at any of the nodes, they will share the reward 50-50, right? At every node both of them are collecting the reward. For example, if Alice is at node 0, he will collect -2 as his reward, and then if he goes to 1, he will collect reward as 4, so his net reward will be 4 plus -2 is 2. So in this way, if both come at the same node, they will share the reward. So if Alice and Bob are at 1, they'll share the reward. So Alice will have -2 plus 2, which is 0, and Bob will have -4 plus 2, which is -2. So this is how it works. And then Alice will proceed to go further, right? He might come to 3. Now if Alice is at 3, okay, Bob has already collected the reward from 3, so now the node 3 is empty. Alice will get nothing from node 3. Okay, similarly Alice then goes to node 4. Okay, 4 is not touched by any of the two people except Alice. So Alice picks up 6. Okay, so now in the end Alice has the reward 4 plus 0 plus 2 plus -2. So Alice has the reward 6. This is how it works. Okay, so now what we need to find is we need to find the maximum income that Alice can get. Alice is only going to travel towards any of the leaf nodes. Okay, so now how to solve this? Okay, so here what we need to understand is that Bob has a fixed path from its starting node towards 0. Okay, also this graph is not having any cycle. Okay, so that's also good. Now let's consider, this is our graph. Okay, 1, this is 0, 1, 2, 3, 6, 7. Okay, so this is our initial graph, let's assume. Okay, so Alice is at 0 and Bob is at, let's say Bob is at 6. So now Alice starts going towards, let's say 5. Okay, so it will go here, then Bob will also move here. Okay, then Alice might go to 7 and Bob will go to 0. Okay, Bob has no other choice but to go to 0. So this is how the question is framed. Okay, so now what we need to find is we need to find the maximum reward Alice can get. So now how to do it, right? So how to do it? So before finding it, what we need to find is we need to find number of steps Bob takes to reach any of the nodes in his path. Okay, so for example, if he is at 4, he'll take 0 steps to reach 4. He'll take 1 step to reach 1 and then 2 steps to reach 0. Alice in on the other hand takes 0 steps to reach 0 and then 1 step to reach 2, 1 step to reach 5 and then 2 steps to reach 4, 2 steps to reach 6 and 7 and 2 steps to reach 3, 1 2 1 2 1 1 2 1 2. Okay, so this is how it goes. Now as you can see, if Bob and Alice meet at here, right, because see, both of them have equal step values here, so they will share the reward here. Okay, but if Alice goes to 4, right, Bob has already collected this reward, so Alice will not get any of the reward from here. So we need to make this step values for each number in the case, for the case of Bob. So to do that, what we need to do is we need to first make an adjacency list for the graph. So let's make one. Also we need to find the size, number of nodes. So that's it, this is it. Okay, and the size n. Okay, so now let's make it. We'll also push this way because the graph is undirected, so we need to connect both of them with each other. Okay, that's good. We have created the adjacency list. Okay, so now we need to make a recursive DFS function here which will find these values for us. Okay, so now how to do it? Okay, let's see it briefly. You also need to have some prerequisites for DFS, how DFS works, and how recursion works. Okay, I hope you have it already. Let's begin. Okay, for example, if Bob is at 4, okay, so now Bob is at 4. Let's mark this node as visited, then it goes to another unvisited node. Okay, now he's here, it's unvisited. Okay, we are also passing a step value. Okay, so it was 0 here, then it became 0 plus 1 1, then here is 1. Okay, then it also went to another non-visited node which is 0. Now the value became 2, right? 0 plus 1 plus 2. Okay, now we have arrived at 0, which means that 0 is children or grandchildren of 1. Okay, so 0 will return true, and the value, step value 2, will be assigned to 0. For that we'll use a vector. So 0 1 2 3 4 and so on. Okay, so for 0, step value is assigned to. Okay, that's good. Oh, now this function returned true. For 1, if 1 finds this as true, the step value will be assigned to 1 as 1. So let's assign it 1. Now 1 will again return true to 4. Okay, now 4 got the value true, so this step value will be assigned to 4. So it's 0, right? All the other branches don't have 0, so they'll always return false. Okay, so that's how it goes. Okay, that's nice. So let's make this recursive function. Let's make a lambda function which will also let's make a vector. Initializing it with int max. If node is 0, step of node will be st. Okay, and then it will return. Okay, that's good. Now we also need to mark the node as is visited. Okay, so let's do it. Oh, we have not declared that vector yet. in initially all the nodes are not visited. Now we need to iterate through all the children of the current node. And check if they are not visited. Then check if that function returns true, if that particular children returns true. Okay, so here 3 is returning false. If 0 returns true, right, it will. So if ds and st plus 1, because number of steps will be also increased by 1. This is st means steps. Okay, so we will just assign the current received st value to our node. So step st equals to node. And then return. Cool. And in the end we'll just return false. Okay, so the lambda function is completed. Let's run this lambda function. We are starting from the bob position and step value is 0 initial. Okay, cool. Okay, now we also need to recycle this. Okay, now we have these values. Okay, which values? These values. For example, if bob is at 4, so these are the step values 0 1 2, right? We have these values stored in the vector. Okay, but now what we need to do is Alice is starting from 0, then he'll go down on the graph, and then we'll pick the reward until he reaches the leaf. So for this Alice, we also need to keep track of number of steps he went through, because if his number of steps are as same as above, which means that both of them encountered at some node. Okay, so we also need to make DFS for this. Let's do the same. Void. This will be the node, this will be the previous collected reward, this int, and this will be the step value. Okay, DFS2. As I said, these are the values. Okay, it will not return anything. First of all, if the node is already visited, we don't want to do anything, so we'll just return. And then now we have to mark current node as true. Okay, now is the step value of the current node. Okay, now see here. Okay, Alice is standing here. Okay, so now Alice's step value is less than that of Bob's step value, which means that Alice reached here earlier than Bob. So Alice will pick the entire reward. So if st is less than step of node, also we need to keep track of all the values in the graph. Okay, that Alice collected at each and every node. So let's initializing it with int min because he might collect some negative value which can be the maximum also. That's why we need, this is like negative infinity here. Okay, value will be equal to, so now new value will be equal to the previously collected value plus the current amount of that node. Okay. Else if this is, if this condition is not true, if st equals to step, right, if both of them encountered on the node at the same time, which means that if both of them had the same step value, we have to half this. Okay, but if none of the conditions are true, if Alice reached here, if Alice reached here, right, here the step value of Alice is more than that of Bob, which means that Bob already collected this value, so Alice will not get anything, is equal to only pref plus 0. Okay, so this is the thing. Okay, now we also need to perform the same thing for other nodes, for other children. Graph node, also checking the same condition. Oh, this is also, you have to perform the same DFS for other values. DFS to child, and the value will be value of node and st plus 1, because if he goes to the next node, the number of steps will be st plus 1. Okay, cool. I think this is pretty much done. Let's complete this lambda function and let's call this function. Okay, the initial node will be 0, the previously collected values will be 0, and the number of steps will be 0. Okay, so we are done. Now what we have is, we have all the values that Alice has collected on each and every node, but we don't want to compare the value with each and every node. We only care about the leaf values. Okay, so how to detect if any node is a leaf value? It's in degree, like, right, like how many, like to how many other nodes that node is connected to. For example, 3 is connected to only 1 is connected to 3, so 1 is not a leaf node. 2 is a leaf node because it's only connected to 0 by only one bond, and 5 is not a leaf node because it's connected to 3 different nodes. So to find this, to find this, we will just calculate the in degree for each and every node. Let's do that. Okay, we can just do that here. Yep, we have increased the in degree here for both the nodes that are connected with each other. For both of them, in degree will be increased by 1. Okay, so now what we'll do is, we will traverse through this in degree vector, then with whichever node has an in degree of 1, we will just pick the maximum out of those, right? So let's initialize our answer with, I am starting from 1 because 0 node cannot be a leaf node. if n degree is equals to 1, yep, it's done. And then in the end we'll just return answer. Let's see how this goes. I hope there are less silly mistakes by me. Line number 16. Oh, I forgot closing this bracket. Let's run it again. This is a hell lot of code, and I am sure equal to step of node. Yep, makes sense. Let's run it again. I don't want any more. Oh, child. In degree. There are so many human errors, man. I can't tell you. Yep, both our cases went correctly. Now let's submit it. I hope it's correct. Yep, it got accepted. So that's a great news for me. So here let's try to find the time complexity of this. Okay, we are traversing like this. Just a minute. Okay, we are traversing in the first DFS we are traversing like this. Okay, and in the second DFS we are going through the entire tree. Okay, so the time complexity will be big O of n in this case. Okay, at every loop we are just doing the linear traversal. Okay, so time complexity will be linear, and space complexity is also linear, because we have not used two-dimensional vectors anywhere except here, but here also the second dimension is limited to 2 only. So this is also a linearly dependent piece of memory. So space complexity is also big O of n here. So yeah, that was my tutorial. I hope you like it, and see you in the next one. Thanks.